Hello, my name is Terrelonge, and this is my 555 timer circuit. The parts needed are one 555 logic chip, two 50 microfarad capacitors, two LEDs, one 4001 logic IC, one 4069 logic IC, one 358 logic IC, a 5-volt power supply and power jack, wires. You need two 47K ohm fixed resistors, two 10K ohm fixed resistors, one 100K ohm fixed resistor, three 457K ohm fixed resistors, one 1K ohm fixed resistor, and one 470 ohm fixed resistor. I will be explaining this with Benny's schematic because I believe it's comprehensive yet very easy to understand. So there's basically three parts to this circuit. There's this voltage divider here from 5 volts to ground. Then there's the outside, which is like 100K, 1K capacitor, and then there's the gates here. So what the voltage divider does is divides takes a third off the 5 volts every time it goes through resistors. So there's 3.3, 6.7, and then these comparators. When the positive input, how they work is the positive input is greater than the negative input, output a high. If this negative input is greater, output a low. So say this starts, it turns on. We just plug it in. All right, nothing is coming in from the capacitors. No charge here. So it means this is higher. This will output a high. It means this will output a high, and this will do the opposite of this input. Or outputs are, this will do the opposite, so this will output a low. All right, this means the capacitor could charge up because there's no way it can get to ground because the transistor cannot flow unless it has a charge going to its base pin. This means the capacitor will charge up, and then when it charges up, it'll eventually overpower this 1.67 and go into the negative side, and that means this will output a low, which means this output will be a low. Turn the LED off, and when this turns off, this is the opposite of this, of course. So it'll output a high to the transistor. It'll be high. This means that the capacitor can then go to ground and discharge, which means that the 1.67 will then overpower it eventually, and the cycle just repeats from there.